All right, let's get a look at our last example for shell method. So this time we're going to take our axis of rotation, and it's going to be something that's not the x or the y axis, so something off of the standard axes. So find the volume of the region enclosed by y equals 2x, y equals 0, and x equals 3. And we're going to rotate around x equals 4. So let me go ahead and sketch this out real quick. So again, it's always good to have a little picture of what's going on here. So if I took 2x, so something like this, and then y equals 0, we know that that is going to be the x-axis, and then x equals 3. So I'll go ahead and draw x equals 3. And we're looking at this region right in between the three functions that are given. And we're going to go ahead and we're going to rotate around x equals 4. So here's x equals 4. We're going to go ahead and we're going to take our height of the function and we're going to rotate it around that. So we are rotating around a vertical line, so it's just like the y-axis. So we're going to have to be in terms of x. Okay, so good thing is we already are in terms of x, given functions are. So we can go ahead and start setting up our integral. So rolling through the formula in our heads. So 2 pi times our radius. So our radius, in this case, remember radius is going to be the distance from our axis of rotation to wherever our, in this case, our x value is. So we have to start at our axis of rotation, and we have to go to our line. So if we drew that height, okay, we want to be parallel to the axis of rotation. If we try to find what this distance is, and we did something similar with washer method, we need to think, what's this distance? Well, from the y-axis to wherever a line is, that's x. And then from the y-axis to our x equals 4 line, the axis of rotation, that's 4 units. So we're going to actually take our axis of rotation and we're going to subtract x. That's going to be our radius. Okay, because we want that distance right here, 4 minus x. And then we want the height. So the height is defined by our function 2x. So we can go ahead and multiply by 2x. And then we need to be from 0 for the x to 3. So we can go ahead and distribute the 2x, clean it up a little bit, and then integrate from there. But the key is here is whenever we're not on the y or the x, that's not our axis of rotation, we need to think about what that distance is. In this case, it was 4 minus our x value. If we're rotating around a horizontal, we're going to be doing something minus a y. Or, sometimes they get complex and you have to draw things out and think about what your radius is. That's the most complicated part of the shell method. So that concludes that. If you have any questions on the work, let me know. And that's it.